Next up on our list is the stylized dome effect. Let's break down how everything works here. But before that, all files will be available in the description. All links are right here. Download updated project files from Patreon. If it's more convenient, you can download it via Fab right here. Also, if you need the hologram shader or the dome shader separately, I've put them right here. You can download them from there without any extras. If you're interested in other shaders, you can go to my Fab page. There will be others there too. For example, here are the stylized domes version 1, and this one, which we're about to look at, is already version 2. If you've come here to learn, to understand how everything works here, I assume you already have a solid foundational knowledge of the fundamentals. If not, check out this playlist. I'll attach it somewhere right here on the screen to make it clearer and more convenient for you. If there's something you don't know, I would strongly advise you to first watch this third video from here. Alright, let's take a closer look at how everything works here. First of all, let's examine what kind of specific settings we actually have available in this menu. First, we have a setting that lets us specify exactly how bright the opposite, backside, or the inner side is. Now, since this shader is translucent and the backside is visible, we might want the backside to be a bit darker for realism, so we've provided separate dedicated settings for that. Next, we can move on to the background settings. Since we've turned everything off, leaving only the background, now let's see what settings are available here. First, we have settings for blending, color, and hue variability, adding hue variability, their saturation, and so on. Well, anyway, you'll figure out all these settings. There's a Fresnel setting here. It allows us to specify how sharp the lines should be. If we set a high value here, our edges will be too sharp. Basically, I think everything else will be clear to you. Just play around with it, see how it works. Now, as for refraction, we've turned everything off, making our dome completely opaque. Let's add a bit of strength, and we'll see that everything behind this dome starts to distort. We have settings for, say, contrast. We have settings for texture size tiling. That is to say, we can specify a significantly large number of repetitions. We can also specify the specific speed and velocity of the movement while maintaining the exact same level of visual contrast, which is to say, adding more sharpness to the lines, the definition of the edges, and other similar details. So you can also take a look, play around with it, it's all very simple. Next, we have the camera settings, so when the camera approaches, the effect starts to fade and we smoothly move inside. These settings are responsible for that, so we've left only the dome settings. Let's see how it performs here. First, we have the texture itself. We have the distortion texture. If we set a high value, the texture will distort too much. We have the movement speed for this texture. There are also Fresnel settings, that is edge settings. How sharp they should be, you specify that too. These three settings. We have offset settings, how the texture shifts, how much it moves. In addition to the power setting, we also have a dedicated brightness setting. That is the adjustable brightness range for the display. There's desaturation, that is to make it black and white. There are speed settings, so we can set it in motion. And there's a size configuration setting for the distortion texture. So if we set a significantly lower value, the waves will be quite large. If we set a much higher value, the waves will be much smaller. So these are the waves, ripples, and distortions. Then we can also add tiling for the texture, which means duplicating it, creating a repetition for this space texture. Next, we have the edge settings. If we disable this setting, you can see that we have a sharp line here. If we want the effect to fade out where it comes into contact with any surface, then we check this box. It's actually checked by default. Then we can switch the mode from gradually fading out or to vibrant highlighting, that is, to glowing. When we check this specific box, we see that it immediately illuminates here with this overly bright golden light. And that is primarily because our specific distance value is currently set to exactly 100. We will switch it now, make it much smaller, let us say to 15. And then we specify some particular color and its overall brightness level. In this way, now exactly where it touches the surface, it will start to glow. The very next checkbox determines whether we actually need to preserve the hues of our space for this line of ours. If we uncheck this box, then our line will be solid, just like this. If we check this box, then it will also take into account the texture of our space. And the last thing is these textures. Just specify which textures you want to use. So let's turn everything off and go in order. First, what do we need? We need to set the blend mode to translucent, switch it, and make it semi-transparent. What is blend mode? There will be a tip here. You can watch the initial video on VFX. Then we set the shading model to unlit. Why do we do this? Because our effect is unlit. For it, it ignores all incoming light from any light sources, be it the sun, a light bulb, and so on. Because the effect itself, it emits light on its own. Therefore, it is not processed in any way. It doesn't react to incoming light that falls on it. So we switch it to unlit and disable all PBR information, base color, metallic, and so on. What is PBR information? Again, the video is right here. Then we make it two-sided. This is because we want the backside to be visible as well. The first thing we need to do is to take a specific texture map and carefully connect it up to the node. Let's take this texture of our dome and connect it. We see artifacts here. This is logical because, as I already said, it's two-sided. And from the back side, if we look, everything will work fine. If we look from this side, it should process it, meaning it will show both the front section, this front part, and the back part clearly through it. That's why these artifacts appear. But it's fixable. We'll smooth out these artifacts and fix it later on. Next, what are we interested in? Once we've taken this texture, we need to add this configuration. It should already be familiar to you. We multiply to adjust the brightness, making it darker or lighter. Add power. This is contrast. Bright shades become bright and dark ones become dark. And desaturation, it's responsible for making this texture black and white. So in this way, it's colored and now it's black and white. Now if we use the dome texture, we'll get precisely the same result. Then we want to take this result and convert it back to being black and white again. Because as I previously mentioned, masks, they are always black and white and always in the range from 0 to 1. Right? This is the first thing to understand. Next, we connect the Fresnel mask. We should know what Fresnel is. Here's the Fresnel mask, edge selection. So we take our Fresnel mask as usual. We add power, we add contrast, and our edges become sharp. A black center and sharp lines along the edges. Then, as I said, we saturate it, making it in the range from 0 to 1. And then we carefully subtract this selection from our existing space mask right here. By applying this specific mask, and in the end, we achieve edges that are softened. Ultimately, through this process, we get a mask for our dome. Now we have the following final result. So, we've made a start, now we need to add edge highlighting or edge fading with the ability to toggle it. How is this done? First, we have a mask here called distance field. What does it do? It highlights the area where our object comes into contact with some surface. We use this mask to add fading for the water and for adding, as well as for adding foam and also for these edge highlights, as we can observe in this specific scenario for the barriers. This works quite well. We can take our distance to nearest surface node and then divide that value by the total distance and get this mask. We add an additional power setting, that is power, which allows us to have much better control over the final result. We clamp it in the range from 0 to 1. Then we utilize a switch parameter to control the logic of whether we want to use this mask or not. Where we use this mask here, we multiply it together with a specific color value. We multiply this color by the brightness level, then we multiply it by 100. I just approached the setup in this specific manner so that I wouldn't have to manually define an excessive amount of brightness levels here. Then we incorporate an additional switch parameter that allows us to choose whether we would like to utilize our dome texture. That is the dome texture, to add space tints to our edge and to our edges. We multiply all of these values by the mask edge color, and then save the final result into edge color. Now let us observe the result we have obtained. This part should already be familiar to you because we covered it in the previous video when we were developing the hologram shader. Nothing new here. We incorporate two values, designate them to function as speed. We also incorporate two values, designate them to function as size. The only thing is right here we add a coordinate offset to the texture, which is essentially a shift. So we're adding a bit of ability to shift the texture to get a visually compelling angle, a more interesting shot. Then we want to use distortion, but distortion in a different way. Here it's a slightly different method. Select the engine folder, type 4-way here, and you'll see the function right here. Inside it is the logic that makes it move in 4 different directions. And all these directions, all these movements are mixed, that is added to each other. And in the end, we get a result where this texture crosses with each other from all sides. We add a texture, convert it to a texture object. Here we convert it to a parameter, call it distortion texture. We specify a texture for it and connect it right here like this. Then for texture coordinate, we add the ability to adjust the size of this texture. That's it. Otherwise, everything is very simple. If we take this value and connect it directly like this, we'll get an error saying that we need a float 2, but we're using a float 3. What does that mean? As I mentioned, this function uses 3 textures in order to blend them together. Right here, you can see RGB. RGB means 3 channels together. RGB are connected together. This means a 3D vector. 3 channels together. Float 3, however, texture coordinate requires a vector 2, meaning movement along U and V, which is a float 2. We need to convert this motion 4-way into a vector 2. How do we do that? We call up a mask component. Through the mask component, we select the RG channels, which is a vector 2, and use them as a mask for distortion. Just like that. Nothing complicated. In this way, we successfully obtained the texture and the mask for our dome. Let's connect them and take a look. We've connected them like this and gotten the following result. Now let's talk about refraction. What is it and how is it used? First, we have texture coordinates, which are again multiplied by tiling, which is some value. This indicates and determines the texture size. We're familiar with this. We set it in motion using a panner. It's all the same. We use two channels, G and B, to specify the movement speed. In this case, we're using a normal texture here, but you could actually use a noise texture if you wanted. It doesn't really matter. We're using the normal texture as a mask to determine where the refraction will occur and where it won't. So it's usually a black and white texture. In this case, we can see what this texture looks like with white areas and black areas. We plug it into alpha and look at the values from 0 to 1.1. This means that where these black areas are, there will be no refraction, and where the white areas are, there will be refraction. However, you need to understand that for refraction, a value of 1 acts as the default. So if we want to utilize refraction, a value of 1 will signify no refraction, appearing normal. A value less than 0 will be inward refraction, and a value above 0 will be outward refraction. That's why we want to blend from 1 to some number, because 1, as I said, is the absence of refraction. Then we use another lerp from 1 to that value, and the alpha is our Fresnel. You know what Fresnel is? It's edge highlighting. In this specific scenario, we invert these values and invert the Fresnel effect values to generate specifically an edge mask. So the next element we're interested in is the gradual fade effect when we get close to our dome. In this specific scenario, we're using a default Unreal function called camera depth fade, okay? We take this function, incorporate it directly into our material shader graph, and save it for future use. Now, by using this mask, we can seamlessly blend our spherical dome texture with the edge color. Where we had black, which is located at the bottom, we'll use our edge color, and where we had white, we'll use our dome color. It is as simple as that to achieve the effect. Oh, I think this might seem complicated to you. To add the ability to switch between edge glow and edge fade, we create the following setup. I think this might be a bit tricky for you, so let's break it all down step by step. Let's disconnect all of this and just plug in the edge mask. When we connect it, we get the following result. The bottom is black and the top is white. So the bottom is the black invisible part and the top is the white visible part. But what happens if we invert it? What happens is that our bottom becomes white, meaning the visible part, while the top becomes the black invisible part. Okay, now that we have successfully finished and completed that step, we want to carefully select and identify this specific part, this specific mask, and add it to the dome mask. As a result, the bottom part will be visible and the dome mask will be visible too. Why are we doing this? We're doing this because we want that glow at the bottom to be clearly visible. That's the exact reason why we invert it and incorporate it, and we add it to the dome mask as well. We create a switch parameter and set it to true. We use it in this specific way as the opacity. However, what happens? What would occur if we take the edge mask and then multiply it by the existing dome mask texture? Let's observe the final result to see what happens. Let's see. We will carefully connect the components together like this and observe that the entire bottom part has now turned completely black. But that makes perfect sense given the setup. We said that if we just take this mask and plug it in here, the bottom will turn black. And anything multiplied by black, since black is 0, anything multiplied by 0 becomes 0 itself. Black meaning it gets removed. Essentially what this indicates is that this specific texture mask is being removed from the bottom. So if we want to use a fade out effect, we perform a multiplication operation on it and remove the bottom part. But if we want to use a glow instead, we apply an inversion to the values and incorporate it directly into the dome mask. And then we use it as a switch. I hope that's clear to you. If we want to use this glow, then we simply require the use of the dome texture. But if we also need to use the glow, then we will definitely want to use blending. This is precisely the method we use to connect it together in the following way, and we get the ability to seamlessly switch between the glow and blending modes directly within this specific menu, right here. In this specific scenario, in this case, I once again used motion 4-way in order to take this texture and simultaneously move it in 4 distinct directions. I added a straightforward configuration setup that we already know made it completely black and white because we don't need color. We subtract the Fresnel just the same as before. This is also familiar to us. We saturate it, meaning we clamp it in the range from 0 to 1. I'm telling you for the 100th time, you must always clamp masks in the range from 0 to 1. Let's save it as a mask. Here we also have a vector 4 where we use it as the size. So here's the texture size, here's the speed, and here's the intensity, which is the brightness. Let's go ahead and connect this background mask texture and see what we get. We get the following result. The edges that should be removed are outlined in black, and the areas intended to remain visible are in white. Let's connect it to both of the channels and see. In the end, we get a mask that looks like this. What do we need to do next? We've got the mask, but we don't have any color yet. What should we do to incorporate colors? To keep the color from appearing dull or flat, we implement these artistic techniques that let us add different shades of black and white and shades of these three colors. We just take some background color, multiply it by black and white shades, and in the end, we get the following picture. We get black and white shades for this color, then we want to multiply it by the shades of three colors. There are still parameters for the degree of saturation and the degree of blending. And in the end, the final resulting outcome, like this, we then multiply it by a mask, specifically on the background mask. Thus, if we, for example, simply add a blending coefficient right here, it turns out that our mask has effectively acquired the distinct shades of these three specific colors, that is to say, this complex texture of subtle shade variation. It turns out then we just need to write all this into a separate one, that is, redirect it and say that this is the background color. Now after our switch parameter, we need to add this background color. And we need to integrate into the texture, specifically to the dome mask, we also need to add the background mask. We get this kind of visual outcome. In principle, it's the identical procedure we did in the hologram. That is, if you remember, we added these masks here and added lines to the hologram to get this specific effect. We do the exact same process here as well. Otherwise, we add some random noise, which should be our background, add it to the dome mask, and get the corresponding final visual result. So now, in theory, both effects should be clearly visible, both the noise and the dome mask. Okay, then after the switch parameter, again, we apply a saturation node to the signal. That is, we need to ensure that we clamp the resulting mask value strictly in the range from 0 to 1. Then we multiply it by the camera distance fade, which we had set up right over here. It turns out that now, when our camera approaches this dome, it will become dark, and we will smoothly enter it. We have a node called two-sided sign. What does it do? We said that we have a front part and a back side. It turns out that the front part will be highlighted in white and the back side will be highlighted in black. And we want to use it to say that the opposite side should be a bit darker than the front side. Thus, we make the front part lighter and the back part darker. And to determine how dark the opposite side should be, we add a parameter called inside intensity. And the last one is eye adaptation inverse. I talked about it. It allows us, regardless of the post-process exposure, for the effect to always be of the same brightness. We connect the resulting outcome in this way, don't forget refraction, and in the end, we get our shader. All links are in the description, like subscribe, join our Discord service, add our games to your wish lists. See you in the next video.